Why is it so sticky?
Why is it so sticky?
Yeah, like we were from chapter 10 to certain circles and chapter 11.
Because you need to know stuff in chapter 10. It's this chapter. Just as a heads up, on Wednesday, we're going to have a quiz over all the circle stuff. So sections 10-1, 10-2, and then 11-3. That's on Wednesdays. Okay, so we talked about how to find circumference, we talked about arcs, we talked about arc length. Today we're talking about area. We're talking about area of a circle and area of a set. So area of a circle, so where we want to find the circumference of a circle, what do we use?
2 pi radius.
2 pi r, or what's our other one?
Diameter of pi.
Yep. Alright, notice that they have taken a circle and they've cut it into sections, like a piece of pie. Okay? So if we take all these different sections, or these pie pieces, and we arrange them and we stack them, like this, what does this kind of look like? What kind of shape? Yeah, it looks like a parallelogram. Or okay, so it resembles a parallelogram. I know it's been a while since we talked about parallelograms, but how do we find the area of a parallelogram? What do you think is it?
Based on time.
Based on time. Okay, so if we're looking at these pi pieces, if we're looking for base and height, what's the base of this parallelogram made up of pi pieces? Half what? C. Half C. Half the circumference. Okay, why? Why is it half the circumference? Where does that come from? Why isn't it half the radius? Half the diameter. Okay, why?
Because half the circumference is a diameter.
Okay, not really. Let's look at how this piece is rearranged.
Oh, yeah. Run.
What? Sorry, it's okay. It's a Monday. It's all good.
Half the circumference is the diameter.
Alright, let's look at how we've arranged these pieces. Okay? Now remember that the circumference is all the way around the edge, right? Okay? Let's look. Do they have any edge pieces lined up in the middle? No, they've got all the edge pieces going along down here, right? Here's edge pieces. Here's edge pieces.
Oh, half the match go on the bottom, half the match go on top.
Yeah. Okay, so that's why it's half circumference. Does this make sense?
Yeah.
What have to go on the bottom?
Okay.
Same with our mountains.
So you understand if we take these pi pieces, okay, you understand how we're cutting it apart, right? So this would be like an edge piece, like the crust of a pie. Okay? So if I was going to take all these pi pieces and rearrange it like this, I'd have pi piece here, here's the crust. Pi piece here, here's the crust. Here's another pi piece going this way, here's the crust up there. Does this make sense?
Yeah.
So half the crust ends up down here, half the crust ends up there. So that's why it's half the circumference. Does that make sense for talking about pi? Okay. Which is pretty appropriate because we use pi circles, right? Okay. So then what is the height of this weird parallelogram shape? R. R. Okay. Why is it R?
Oh, that makes sense. Because it says, instead of the circle thingy, it says on that one line, it says R, so that's like the radius. So that it's like relating to the pi thingy or whatever.
Right, because I know radius goes from the center of the circle to the opposite end, like if I was going to cut the pi piece again in half, right? So again, if I take a pi piece and go from the center to the edge across, I get radius.
Yeah.
Okay, so we know it's radius. Okay, so the area of a circle we can write as the base times height. Where we said base was 1/2 times the circumference times the height we said was r. Okay? Okay, but how else can we write circumference? Not circumference times diameter. How do we write circumference? That's what I'm looking at right here. How can I rearrange and rewrite circumference? pi r.
Oh.
And we can use 2 pi r. That would be our circumference, right? So I would have half times 2 pi r times r. Because I'm just rearranging, putting in 2 pi r in there. And for circumference. Okay, now let's do some simplify. What's half times 2? 1. So half and 2 cancel out. What's r times r? Don't say 2r. R squared. So I can say this is pi r squared. So let's only come up with the formula of a circle. No silly pi r. Ha ha. I just got that. Have I not told you that one yet?
Yeah.
Oh,
Really?
what?
Oh, I don't remember that.
Don't you?
Oh, I'm sure you did.
Yeah,
Something like that. That's so funny.
To say that's like my favorite math joke ever. Alright, so we found area by using pi r squared. That's important. Alright, example 1 says what is the area of the circular putting green and round to the nearest square foot? So in this case, they give us 20 feet. What is that? That's the diameter. But in order to find area, I have to have
Ladies.
I have to have
So your intersection.
Why not do it simply?
Order of operations. Are we going to take 10 times pi first, or are we going to take 10 to the squared first? And squared first, order of operations always do exponents first. What's 10 squared?
100.
And 100 times pi gets us about
314.45.
3, 1, Yep, and we're rounding it to the nearest square foot. What are we going to round it to?
22. Oh.
Oh, 314.
Feet what?
Squared.
Squared circumference area.
Well, that was easy.
Yep, these aren't too bad. Alright, let's look at the arbitrary target. It says the arbitrary target shown has a radius of 12 inches. What is the area in terms of pi? Remember, in terms of pi means we are not going to take a times circle and forward. We're going to leave it with that symbol in it, right? Okay, so area is equal to pi r squared. What's our radius?
And it's 12. So area would equal
What's 12 squared?
144 pi.
144.
Does pi go in the front or the back?
I always go here and that. Yep, inches squared. We treat pi as if it was an x. Like I can have x times 12, but usually we write it as 12 times x. We always put pi in the
Just remember pi.
That's your favorite number, isn't it?
144. Yep. Yes.
Okay, out of curiosity, does the variable x by itself have a value? Because I tried typing it into my calculator once and it was like 10 something.
Say that again.
Well, you know, because you said treat it like marks. This is kind of just a little. So pi has a value. So I tried typing just x variable in my calculator and I came up with a number.
If it was true, somebody probably said let x equal some number when they were doing an equation. That's why they gave you that number. 'Cause it's so It's just whatever is last and whatever the people said, like this, let x equal whatever number. That's what it's like. Otherwise, x would be.
Okay.
Does that help?
Kind of.
Kind of like, yes, we treat pi like a variable, but pi is actually a number. 3.14159 blah. Just like e, when you get into like logarithms, we're talking about e. E is 2.71 something. Like, but we usually use e as a variable, like pi. We use pi.
Okay.
Alright, anyway, go over this. Okay, example 2 says find the radius of a circle. They give us the area of 95 square centimeters and round to the nearest 10. Okay, so area equals pi squared. In this case, we know the area, so we're going to put that in for A. How are we going to get R by itself?
Oh, I know.
What do you think?
We divide by pi, and then after we divide by pi, You take the square root of that.
Right, because if we're divided by pi, we have r squared left. And then to get rid of the square, I have to do the opposite, so I take the square root of 95 over pi. In your calculators, make sure that you put this in parentheses, otherwise it may think you're just taking the square root of 95 and not the whole thing. So find the square root of 95 over pi. We're rounding to the nearest 10. Come on, buddy.
Mine doesn't let me.
I have not 5.49903.
I have 3.1.
So we're rounding to the nearest 10 about 5.5 centimeters.
How do you guys know? What do you mean from the troubles I got?
They should put extra 7 friends. Yeah, I have.
So let's go. 95, 5, 5. So don't do your fraction.
You're at 5.
The upper one is just rounding 5. We want to go. Alright, you want us to come to the calculator? It's yours. You have to go your x and then equals the negative square. Alright, anybody else? Okay. Looking at the it says the area of a circle is 196 pi square yards on the diameter to the nearest 10. So the only way we can find area is pi r squared, which means we have to find the radius first before we can find the diameter. So area is 196 pi. What are we going to do now? Oh, not yet.
What are you
Get rid of pi.
Get rid of pi. Okay, so pi's just cancel. Just put it over pi on one side and get rid of it on both sides. Now what do we do?
Square root.
Now we do it. 14. So to the nearest 10 would be about what?
14.
Okay. But I don't want to round again. I want a big long decimal on your
That's
answer.
14.
It comes out even.
14 had 14.9.
Oh, all right. Okay. So I should put an equals of a squiggle equals. Okay, 14. But what are they asking us to find?
Diameter.
So what are you going to do?
Times by 2 is 928.
Yours. Okay, any questions up front? Okay. Sector of a circle. Sector of a circle. Lindsay Taylor's a travel background with things? I know.
No.
Okay. Okay, so sector of a circle. Sector of a circle is like a piece of pie. Okay, we're cutting the circle from the center to the edge somehow to figure out like a piece of pie. Technically, it's a region bounded by an arc. Oops, no, there's an and central angle and an arc. In other words, it's a fraction of the area of a circle. Remember how we talked about finding the length of an arc was like a fraction of the circumference? Well, a sector of a circle is a fraction of its area. Okay, so the formula looks really, really similar, doesn't it? Okay, let's remember what the length of an arc. We said it was the measure of the arc over 360 times.
2 radius off.
Which was really the
The formula was circumference.
right circumference. In this case, instead of taking it times circumference, we're taking it times area of the circle.
Wait, so the other one degree over 360 times 2 pi r.
Which would be the circumference if we're finding part of the circumference. Here we're taking it times the area of the circle, which we're finding part of the area of the circle. Okay, alright, so example 3 says circular pizza has a diameter of 12 inches and is cut into 8 congruent slices. What is the area of one slice to the nearest 100? I think we need to draw a picture. Alright, here's our pizza. And it says we're cutting it into 8 congruent slices. Our lines were nice and straight and congruent. There would be our pizza cut into 8 pieces, right? Alright, so if we're trying to find the area of one slice, okay, that means we need to use our area of a sector, which means we need to know the measure of an arc, and we need to know the radius. Well, what does it tell us in the problem already?
That the diameter is 12 inches and average by 12 inches by 2, then there would be 6 inches, so the radius is 6.
So the radius is 6. But we also need to know what the measure of our arc is. We need to know this angle, right?
Well, if we cut it into 8 slices, you know, a full circle is 1 for 360, then 360 plus that 8 is 25.
You were right. Okay. We can use what we just did so far.
That's the arc measure?
This would be the measure of the arc. That would be our angle in here. 45 degrees. Okay, so now we're just going to plug it into our formula. Measure the arc. 360. Times pi radius squared.
Here's what the 45 over 360 can be reduced to 1/8.
So 1/8. Okay. So 1/8 times pi times what? 6 squared? 36.
You could also cancel out the 36 and the 360 and 364.
10. Okay, that would also work, yes. Can I reduce what we have so far? At least by 2, because they're both even, right?
You can divide by 4.
Divided by 4. So 8 divided by 4 gets us 2. What's 36 divided by 4?
9.
9. Okay, so then I would just have 9 over 2 times pi. Would be our area of one slice, but it says nearest 100th, so they actually want you to take it times
14.14.
What inches squared. So if it's a leave it answer in terms of pi, then it would be the 9 over 2 pi, since it says there's hundreds. Actually, we didn't even have to do the simplifying, we could just plug it home. Any questions on what we just did? Alright. Is it really similar? That's the we're doing. It's just that. Just plug in the formulas. Okay, let's try B. It says find the area of a shaded sector and leave your answer in terms of pi. So don't actually take it times 414, just reduce that fraction. Okay, so remember we have the measure of an arc over 360 times pi r squared. Okay, so measure the arc in this case is going to be
It'd be 50 feet.
radius is 4. So I would just think 4 squared gives us 16. So what's 53 times 16?
820.
And then you just need to reduce that fraction. I know we can at least divide by 2, or divide by 4, probably, maybe. Yeah. more than that.
Oh, we can divide by 8. Well, the top one we can divide by 8. And the top one divide by 8 will be 106.
So can we take 360 divided by 8?
Yes.
Yes.
345.
So 106 over 45 pi. Are you using any farther? I don't think you can. So you can't take out I think that's as far as that goes.
So if pi is like on the positive fraction, it's the same thing as being active.
That should be feet squared. Do you guys feel like we need to do the other two examples? We just got it.
No. I'm doing the other ones as well.
Okay, we can do it.
That's
I want to point out something on this very last one. On this very last one, what is the measure of the arc of the area that we're trying to find?
295 degrees.
Right, okay, so in our formula, we would not put in 65, because that's the area that's missing, right? We would find the measure of the arc of the ellipse. Make sense? Okay, just wanted to point that out. Do you want to go through anything else? Okay,
what order did we do these notes in? The draft reminders and everything got mixed up.
oh, we did 11-1, 11-2, and then 10-1, 10-2, and then 11-3. Questions, comments?
Is it in the book today?
It is a worksheet today.